Alrighty, here we go. First tech active, at least as far as the group classes are concerned. So maybe it's worth touching on a bit about what a tech active exam actually looks like. Well, they recently changed it. That's for one thing. They've changed what the visual theme of it's like, although the overall structure is definitely still the same. Um, You have two sections. You have a multi-choice section, which is 20 marks worth, and you have an extended response section, which is 60 marks worth. Total of 80, of course. And then as far as your overall time to complete it, 15 minutes reading time, 2 hours writing time. That's standard, and that has been the standard for probably ever since mathematics has been a thing. I'm pretty sure it's been that way. What is interesting that I think is new is the multis don't go to E anymore. I'm pretty sure they used to go to E. In fact, maybe I'll just quickly make sure that's the truth. Not that it really matters, I guess. It just is what it is. But I'm pretty certain it used to go up to E. Yeah, there you go. Used to go up to E. So a little bit nicer for most people. You've got one less thing to try and rule out. Although, to be fair, by the time you're getting into the exam anyway, trying to rule out those options, you can usually do them in bulk anyway to get it down to 2 possibilities. But for those who are randomly guessing, the floor of your marks is now raised a little bit higher because you've now got a 25% chance across the board rather than a fifth. Multis will tackle quickfire pretty much everything. We've kind of already done stuff like that before in chapter reviews in a sort of localized way of doing quickfire stuff. I feel like the thing that people are struggling with most, though, would be around the section B type stuff. It's extended response, the questions sort of follow on from each other, and so you have to put a fair bit more time dedicated into doing well in the extended response section rather than multis, because multis are pretty much going to be stuff that you see on your textbook anyway. These ones are a bit rarer. So unless anyone wants to do anything differently, if I get feedback to do multis, I feel like most people are going to get most benefit out of doing section B stuff, which right now is just yourself, it would seem. So let's see how we go. All right, question 1. Cool. We got a function. It's a whole bunch of bracketed terms multiplied together. State in terms of A the values of x for which f of x is equal to 0. There's a whole bunch of nonsense there. I'll give you a second to read what's going on there. Let me know how you might go about that.
I'm guessing that we want to find A values where when you solve like the function will eventuate to 0.
Yeah, correct. So you've got this function f of x is equal to all of this stuff. You want to solve for where f of x is equal to 0. Correct. Yeah, that's the broad strokes of what we're doing. And because there's a's in this thing, then your solutions are going to have a's in them. Yeah. Now, as far as the actual way of achieving that, what are we going to do? Reminder, this is CAS, by the way. Tech Active Exam. Algebra solve on the CAS? Yeah, precisely. Algebra solve on the CAS is correct. So my default way of doing anything tech active, as soon as I see a function in an extended response, just define it as whatever you want to call it. I call everything h of x just because it's a habit. So h of x is going to be bracket x plus 1 times bracket x plus a times x minus 2 times x minus 2a. And then, yeah, algebra solve. So 3, 1. we're solving for where function equals 0. So h of x equals 0, comma a. No, comma x. You want to have a in the solution, but you're still solving for x-intercepts. And so yeah, those are going to be the answers stated in terms of a. Some of them are going to have them, some of them aren't. This one, you technically didn't really need the cas for this. You could have just remembered that you have null factor law to work off of. This is a sequence of bracketed terms that are all multiplied together that equals 0, right? Null factor law. We can see pretty quickly where all those solutions are going to have come from. And yeah, that's about it for that one. Next up, part BI. Find the values of a for which we have exactly 3 x-intercepts. It's a similar vibes question. One thing to keep in mind, of course, is when you have these sequential parts, it's pretty likely the information from the previous parts will help. I'll leave that up to you guys. For any newcomers who might be lost where we're at, part BI.
Okay, since two of the solutions are already the same,
Mhm.
that means two of the solutions have to be different if we need to have like, exactly three x-intercepts, right? So then
Mhm.
does that just mean that like a is any real number except one?
If you force a to be any real number except 1, well, there are other ways of making 3 intercepts. So the one that you were thinking of was if you force a to be equal to, if you force like this second solution to be the same as -1, that's one way of getting 3 solutions. Yeah. The other is forcing this one to be -1. The other is forcing this one to be equal to 2. This one to be equal to 2. There's a whole bunch of different ways that you can force exactly 3 intercepts. The goal is just to make sure that you have presented all the possible ways that condenses down this list of 4 things into a list of 3 things. Bit clearer the approach there? If so, maybe have a go through and see if you can write down what all those possibilities are going to be.
And a be -1/2?
-1/2 is one of the answers. Yep. That would force the x equals 2a to be the same as the x equals -1. Yep. And then everything else would be different. Yep. What else? I'll give a hint. There's 3 possibilities for it. A equals 0, -1/2, and 2. Yeah, those are all correct there. So the -1/2 we saw, the a equals 2 would be getting the second solution to be equal to the fourth solution. Oh, sorry, hang on. Should that be... Maybe it should be -2, your other answer, unless I'm mistaking which one you're trying to target. Yeah, Michael, you should probably have -2 as that other one. Yeah, okay, cool. Yep, so that would force your second solution to be the fourth solution. And then the other one that's interesting is a equals 0, right? Now, I know I said before I was pairing them up like this. What I actually end up missing was the fact that if you put in 0, these two condense down into each other. So that's the other one. Yeah, those are the ways that you would create exactly 3 x-intercepts. If there's any more clarification around that, feel free to raise your hand and ask. Otherwise, you can apply a very similar idea to getting exactly 4 x-intercepts.
Is this all the numbers except the numbers that we just listed earlier?
Um, pretty much just be keeping in mind what you solved earlier was exactly 3 x-intercepts. So for exactly 4, um, just double check there isn't any other pairs. Yeah, Michael's brought it up. This one includes 1 as well. Oh, excludes 1 as well. Because for a equals, yeah, so why does it exclude that? For a equals 1, what do we have? Oh, because that means you got these two as the. Well, actually, yeah. Why has that happened again? For a equals 1. Oh, right, because a equals 1 gets you 2 solutions, because it makes these two, the first and fourth, a pair, and then these two, the second and third, a pair. So exactly 3 x-intercepts wouldn't have covered that particular scenario. Clear enough why 1 is in that list as well? And just to also highlight how you would now actually present that answer, you would do something to the effect of saying all real. Well, actually, how would you say it? Find the values of a. So you would say, even better, you would go a is an element of all real, excluding, and then all those numbers there, which, let me pull that up again, was -2, comma, -half, comma, 0, comma, 1. So using those squiggle brackets means that each of your individual numbers in there are elements, right? These are the things you're excluding. If you use any other type of bracket, you're technically using the wrong syntax. Okay, otherwise that's that. Now, I have chucked in a copy of this test in the Zoom chat. I don't know if that, for people who join late, let me know if you need another copy of that. I'm pretty sure you should be able to see them. It'd be better for you to have a copy of that to run through because extended responses do cross over separate pages. So instead of me sending a screenshot for all of them, maybe just grab a copy of that. And then Michael, how can we be sure it's only those numbers? We don't want to keep looking for more numbers to exclude. Yeah, I mean, a lot of it's just going to be sort of using your own intuition around how many possible x-intercepts there could be. It's a polynomial, so you're maxing out at 4 because of your null factor law thing. And then just sort of from there, we've already shown all the possibilities for 3 x-intercepts. Then you just got to sort of look back and say, hey, can I make 2? Can I make 1? Obviously, you're not going to make 1 because you've got 2 whole numbers in there. So x equals -1 and x equals +2. Those aren't going anywhere. You're forced to minimize at 2. And so I guess the answer to that question is you still do have to put a little bit of effort into figuring out if you got more possibilities, but it's no more effort than you put into already figuring out exactly 3 x-intercepts. You just got to do another little thing in your head and be like, okay, I need to figure out for 2 as well, if that's a possibility. So it's a fairly restricted scope there. Is that fair enough, how you restrict the scope down? Yeah. And yeah, for everyone else, I have dropped another copy of the PDF, so definitely walk through it that way so you can see the context of the previous questions. But otherwise, okay, let's move on. G is a function. Perfect. There's a new function. Or I guess more specifically, what happens when you get a equals 1. Find g dash of x. That'll be a fairly standard thing. Any thoughts on how we go about doing g dash of x?
Since it's a tech active, do we just put into the CAS?
Yeah, that's it. Just cas it out. No worries at all. Because they did specify that g of x is the same thing as h of x, or as f of x rather, for a equals 1, one of the things you can do on both cases actually is you just define your letter as equaling to 1. And so that way you don't have to redefine the entire function to make it work. You can just do your standard d dx of the function afterwards. They accepted both the expanded and factorized versions of this. I'm assuming because, well, beyond the fact that they are the same thing, maybe Cas's will do different things. Maybe the Casio does expand it rather than factorizing. Not too sure. Point being that both the factorized and expanded versions are fine for that. But okay, that's fairly standard. Just use Cas to solve. Part CII. Find the coordinates of the local maximum of G. Local maximum. What kinds of concepts come up when we talk about maximums? That's something to consider when you're working through how to go about it. Another context clue would be they'll typically further indent things using like III, III, when C is its own like self-contained little thing. And so instead of thinking like, oh, we can look at answers A and B, as soon as you start, oh, sorry, questions A and B, as soon as you have an additional set of indents, it pretty much means that all of the information necessary is located in the parent folder. So when you got CI, C is the parent of that thing. That's another way to sort of reduce the scope of what you're looking at to get more information. Just a little exam tip there. Anyone making any progress? Or should I dive in? Maybe just a thumbs up or so if someone's working on it. Oh, here we go. How do you know? Do you know how we can do Fmax on ClassPad without graphing? Yeah, I think you can just Fmax it. Then there are multiple choices. Multiple choices. Probably because you haven't put a domain on your Fmax. So Fmax will just choose the absolute. Like you probably got infinities there if you're getting multiple values. Yeah, so you've just sort of got a whole bunch of possibilities there. Because if you think about what this graph actually looks like, it's a positive quartic. So it's going to start and end at the top left and right. So it's going to shoot off to infinities anyway. Consider reducing your domain there. Not getting numerical values and getting the function back. Yeah, probably because it's finding infinity. Like maybe if I do it here, and you for, we may or may not get it. Fmax of, I guess it'd be h of x for this one. Yeah, like this cas will just give you infinities. Maybe the Casio just gives you the function back. Part of what you have to do is restrict your domain if you are going to look at your Fmax type stuff, which you kind of have to do arbitrarily, almost. You can graph it and then just get a vibe for what the restriction on the domain should be, but you're probably better off just going about doing derivative equals 0 approach. You've already got derivative on hand. For local maximum, that means you're trying to find a turning point. So that'll be your fastest approach anyway. But yeah, if you wanted to force Fmax to work, you'd probably have to graph it to get an idea of what the restricted domain would look like. No worries at all. Happy to help. But okay, yeah, so we've already got our function. I've defined it as I of x as the derivative. Derivative always equals 0 for turning points. Now, the challenge with this, of course, is you're going to get both minimum and maximums, and also inflection points, actually. Although, if you notice what we have, g of x is squared terms that are multiplied together. You're not going to have any inflection points there. Now, here's our array of possibilities. How do we know which one's a local maxima? Well, a couple of methods. I'll be curious to hear if you guys have any ideas how you would validate. Check the gradient of n minus 1, n plus 1. Yeah, so you just sort of go either side of the values, checking the gradients either side, seeing if you can make your slope. And so you're essentially looking for, like, I haven't checked ahead of time, but let's pretend it's the x equals a half one. We want to test, well, we already know at a half, it's a gradient of 0. You would have to test something like positive 1 and maybe negative 3/4. Because if you look at the values that you have, you don't want to go outside of that boundary. You don't want to cross over to the next one. And what you're hoping to get is a positive gradient over here and a negative gradient over there. That works. Bit time consuming though. So one of the things you can do is, because we've got everything defined in the CAS, is you can go straight to your calculator, or the graphing tool rather, just plot it and then observe from there. This is only a one marker question. You don't have to put any proof around things. And so we can see that's probably going to be the half, right? We had possibilities of, what were they? -1, a half, or 2. You know, you can see that a half is going to be the maximum. So being a one marker, you don't have to put that much effort into proving the thing. So I guess that would be the fastest way of going about it. But yeah, to do that other method, you'd be subbing in your -3/4 and your positive 1 to get your array of values. You can use, yeah. So the other thing about using the analyze graph tool, you have to be kind of cautious with that, because if you, no, not delete. With the analyze graph, when you go maximum, you'll be happy that you got the entire point, which is 0.5 and then 5.06 whatever there. The challenge there is if the value is a harder number, right? Like if it's a decimal that's recurring or an irrational number, you can't actually use that value. You've got to give it exact because the question didn't say to give decimal places. So this will work out fine to get the x value. It just so happens that it's a nice value. But to get the y value, you're not going to write 5.06 down. You're going to come back and then sub in your x equals 0.5 into your original function. And this is the value that you actually go with for the y coordinate. Because remember, we're trying to get coordinates of the entire thing, not just the x value. Yeah. Didn't expect to have so much to talk about for these questions, but fair enough. There is actually quite a bit of a nuance that's going on in these, isn't there? I feel like we've fairly well explored all that. Is there anything else that's lingering that's a bit weird? Anything I should clarify at all? If not, feel free to move on to VCAA. Should also be a bit of a quick fire one. Do we put U or union or intersection for the two ranges? All right. So union means the addition of the two things. It's one thing and, well, one thing in conjunction with another thing, whereas intersection means it's only the crossover of the two things. So based on that, if U is having both and intersection is just what's common, which do you think you'd rather have? U, correct. Yeah, you want to put a union between your ranges. That's it. No worries. Yeah, there's a hint for everyone else. When you do this solution, you will get to two separate domains. Any thoughts on how we get there?
We can just put the derivative into a solve function with
Yeah,
an element.
there we go. Nice and chill. I define my derivative as I of x, so let me go through the solve. We're going to just set I of x is greater, and we are going to use it is greater, yeah? Yeah, just greater than 0. X, that's going to give you two possibilities there. That word or, you're just going to replace with a union. So you can use this inequality setup to do your thing. Although the other alternative is using like your rounded brackets as your two separate using interval notation. So I guess just to be clear on that, the other way of doing it would be, you would say, and this will be probably your most mathematically sound way, you'd say x is an element of -1 to a half union 2 to infinity, using rounded brackets for the whole thing because our thing was just a greater than sign, not a less than sign. If for whatever reason you want to validate that, just plot I of x on your cas, and then, well, plot derivative, I guess I should say, on your cas, and then just be like, yeah, okay, I can clearly see this is where it's above the x-axis. Right, you want to figure out, cool, all right, this is 2, it's above, cool, this is 0, it's above, this is, well, you can estimate it's going to be about a half, which is above. Cool. Anything to clarify? Let me know. Otherwise, have a stab at IV. Two tangent lines off of two separate points. What is the coordinate of intersection between those two tangent lines? They're going on. Good to start with like a high level idea of how you're going to go about it. Coming up with a sort of game plan, if you can, is nice. But if not, obviously you can just start solving things that you know you can solve, and that gives you more information to work with for the next thing.
Since we have the function in our cas, right, we can just do like g of whatever the x value is, and then would we
Mhm.
find the point for y?
As in, yeah, so if you sub in, like, let's say it's the negative root version, g of the negative root is going to give you some y value. Yeah.
Yeah.
What did you want to do with that?
So then wouldn't that give us the coordinates?
It'll give you a coordinate on g, but this question is asking us to find the coordinates of the intersection of tangent lines. So it's a bit of a different thing that you're trying to aim for as the final answer.
Oh,
Um,
okay, my bad, yeah.
yeah. So having this, yeah, there you go, Michael. Do you find the two tangent lines and equate them? Absolutely. That's the overall approach. So, if you want to find where two things intersect, you need equations for those things. So getting tangent lines at these spots, that's what it says, right? Two tangent lines at these spots. If we can achieve both of those, then equating them is going to figure out where their points of intersection are. Anytime you have point of intersection, it's always function 1 equals function 2. Who knows how to speed through that on the CAS? What CAS functions do we have access to? Both the TI and the Casio have the same things for this. Who knows it? there's an inbuilt function that'll be really helpful to have instead of having to do it all by hand, finding tangent lines. Yeah, tan line. Nice. For us, for TI Inspire users, it's going to be the tangent line function, but it's the exact same shit. You give the function, so we wanted, yeah, it is h of x. Yep. Then the next thing is going to be the x value for which you want to take the, oh, hang on, is it? Yeah, I think it's the value and then x. Let's find out. It'll be one of those orders. Negative root 3 plus 1 over 2, comma x. Yeah, okay, I did it in the wrong order. That's fine. Comma x first. That's tangent line 1. Tangent line 2 is just the positive root version. And then, yeah, to finish it off, as we said, grab equation 1, make it equal to equation 2. Does that make sense as an answer, making it, hitting it equal to x equals a half? I guess so. Another thing, yeah, so as far as proving your answer ends up being fine, one thing you can do is define each of these tangent lines as their own function. Hop on over to the graph of your function. This is the derivative, so hop over to the graph of the thing, and then actually do the do those tangent lines on the same thing, and then see where they intersect. So that'll be another way to see, hey, look, did I actually get the right value there? Now, reminder, it is a coordinate, not just an x value. So we have our x value of a half. We already know what the y value there is. We've kind of already grabbed that. Wait, sorry, no, that is a bit of a misnomer on my part. We do need to find it additionally, because it's not necessarily guaranteed to intersect the function at that point. So now that we have the x value, what are we going to do to get the corresponding y value for this one? Almost said the wrong thing there. Yeah, I'm even looking at the answers now, and VCAA's roasting me. A common incorrect answer was to do what I was about to just say. It's a reminder. Yeah, sub a half into, well, not g of x. That's what I was about to say. That was actually incorrect, because instead of me defining all those things and taking some time, here's the problem statement. So we have our g of x, which looks something like this. Yeah, into the tan function is correct. Yeah. Now we're taking tangent lines at, I don't know, we'll just call it here and here. They'll shoot off like that, slightly above it. And so yeah, you sub it into one of the tangent line functions. Doesn't actually matter which one, because they both share a point there. I probably wouldn't bother defining it. There's only one spot to put the x in, so putting a half there isn't going to be the end of the world. That's going to get you the y value that you need. 27 on 4. Any further clarification why we needed to pick a tangent line function rather than g of x? If not, feel free to move on to the next question, part D. a fair bit going on again, especially for a 1 marker. I haven't really looked into it too much, but I think the fact that it's f for which a is -1, I think that matters. Or at least it could be used to simplify the amount of effort that you put in. Yeah, maybe not. Anyone got any ideas on how you might go about it? Cool. Okay. So we're trying to force it translation wise to force H to now have a local maximum at the same coordinates that G has a local maximum. We already know where the local maximum is for G. So if we want to figure out how to get from the local max of H to the local max of G, we first need to figure out where the local max of H is going to be. So let's actually grab that value again. What was it? So we wanted half comma 27 on 4. So the local max of G is half comma 27 on 4. So we want to get it there from H, but we don't know local max of H. How are we going to get that? That'll be a nice stepping stone to get there. Graph, yeah, totally. So if I go ahead and plot H, we can see where the local max is located. Use our graphing tools to get it, at least to get an initial value. We can see it's probably going to be x equals 0, but the y value, come on, give me 0. It's not going to give 0, huh? I wonder if that's just the graphing tool being a pain. Let's do a slightly better way of going about it then, maybe. So where does derivative of h equals 0? Yeah, so it is definitely x equals 0 there. And then h of 0 is 4. So from that, we can say coordinate is 0, 4. So using only translations, how do we get from here to here? That is now the question. Half unit left and 11 over 4 up. Well, it wouldn't be half unit left because you've got to go from 0 to positive half. Yeah, so right's good for that. And then for 11 on 4 up, seems a bit off. The answer's supposed to be 17 on 16, so let's see what's going on there. So we do the difference between 27 on 4 and 4. Yeah, 11 on 4. Yeah, 11 on 4 should be fine, so why have they got different? Half unit right, 17 on 16 up. Am I looking at the wrong coordinate then? 0, 4. Describe a sequence of transformations of H. Image is going to have a local max at the same coordinate, so that is a G. Why do they say it's 17 on 16? Yeah, I've got the same answer as you guys. Half right and 11 on 4 up. The answer in the thing is saying 17 on 16. I'm looking at the right thing. H, did I use H properly? Is H defined correctly? Find out. X plus 1, X minus 1. Yeah, 17. How'd you get 17 on 16? Where's the, what error have I made?
I just took the exact value and minus 4, and it just gave me 17 on 16 in my CAS.
The exact value in the minus 4. So you use 27 on 4?
Wait, sorry?
So this exact value, 27 on 4?
Oh no, I used 81 on 16.
81 on 16. Have I? Okay, so that's probably the reason why. Now, why is it that it's G? Oh, yeah, I used the tangent line one. Ha. Yep, that's why I was doing stupid. Yeah, okay. We didn't want to get it from. Yeah, this is not the local max of G. This was the that was the intersection point of the tangents. Yeah, it should have been the other function. Sorry, that's my bad. Yeah, you got that right. Look at that, beating me. Awesome. Yes, that other value we wanted was, what was the other one? Sorry, what was the actual y it should have been?
It was 81 on 16.
81 on 16. Thank you so much. Cool. All right. So that's my fault there, guys. Sorry. Cool. All right. That's that one. Next up, using a dilation and translations, describe a different sequence which would get the local minimums to be the same coordinates as that of G. Okay. So, again, comparing where the local minimums of H currently are, getting those probably from a derivative equals 0 approach, and then comparing those to the local minimums of G, which is not plotted. So let's do that. There's some kind of dilation, and then, yeah. Oh, I remember this one being really weird too. The only requirement is to force the local minimums to be at the same spot. What can we do to get our head around it? Or at least what information would be nice to know before we start diving into it super deep to get our transformation set.
The original minimum coordinates.
Yeah, precisely. Now this one you could use fbin to grab both of those instead of doing derivative equals 0. I've kind of already got a derivative equals 0, so we could just sort of reuse those values. So derivative of h equals 0. Let me just double check that's what we care about. Yeah. So getting both of those, and then to get the y coordinates that correspond with that, obviously you'll plug those into h. Grab that. And I'm assuming the other one's also going to be -9 on 4. Cool. So we have a new thing. So ignore this. Got two mins for h. Those are going to be plus minus root 10 on 2, comma, minus 9 on 4. And we want to get them to be the local mins of G, which I believe we already had. Did we already have them? Either way, we can get them. Idx of G. Grab them. Equal to 0, x. So that's going to be the negative 1 on the 2. So G of negative 1, I'm pretty sure that was 0, right? Yeah. Cool. So that's mins of H, and now we have mins of G, which are both going to be now negative 1, comma 0, and 2, comma 0. So we need to make these map onto these. That at least gives us a bit of a direction to make it happen. As far as making it happen, a bit more of a challenge. And the key to recognize here is you only get one dilation, but you get as many translations as you want. %5 pass rate question, by the way. Tough one for a lot of people. About 19% of people got at least a mark out of it. I think one thing you might want to care about is that the relative spacing of the minimums will be the same. That's probably the only thing you can do with a dilate factor. We want to make sure that the horizontal distance of them are identical. They already have the same vertical distance. They're both like horizontally located with respect to each other. If you compare the overall distance between them, so for instance, distance between is going to just be root 10, right? So the difference between these, you got a distance of root 10. The distance of the other ones spans from negative 1 to 2. So distance of 3. So if you were to just do horizontal translations, you would never quite make it because they're further spaced apart from each other. We can kind of see that visually speaking if you look at how one of them's a bit like thinner than the other. It's a bit more compressed. That's the prime use of a dilate factor, trying to ensure it's stretched in a way where when you go ahead and do your translations, you can just shift it directly over to where you want it to go. So you can be pretty aggressive with how you choose a dilate factor to make it happen, and then use as many translations as necessary to then just sort of put it eventually where you want to put it. So we're trying to go, well actually, so the reason why you're struggling to figure out why we got or how we got the dilation is because I haven't actually told you the dilation yet. This is just sort of conceptually speaking as to how we might start making a decision as to getting our dilate. So we want to choose our dilate to essentially make it so that the spacing between these points is going to be consistent, because translates will only map it from like uniformly in a certain direction, but you're not going to ever be able to achieve that if the actual gap already is too different between them. So if we're trying to get, what are we doing? From H to G, the current spacing of H is root 10. The spacing in the, so this is horizontal spacing, mind you, the current spacing of h is root 10. We want a target spacing of 3. So we want to essentially compress, well, actually, I guess it would be stretch, actually. Root 10 is a bit smaller than 3. You want to stretch this spacing to make it equal to this one. What kind of multiplication could we choose? Because dilates are all multiplications, to make this equal to that. That's kind of the logic you have to follow. It's again, this is what, 5% pass rate? What did I say the figure was? Yeah, 5% pass rate. So feel free to jump in and ask me to explain it in more detail if that's not great. Our target is to multiply this to make it look like that. Negative 3 times p equals negative square root 10. Yeah, okay, that's fair. You could do a CAS solve and just let the CAS do the heavy lifting. That's cool. We're trying to go from this way to this way though. So you'd put the p value on this because that will be the actual number that you care about. Because this is the spacing of h and then you want to get to the spacing of g. The quick hack, by the way, without having to do a CAS, is just whatever number you see here is a division. That forces it equal to 1. And then whatever number you see here is the multiplication, because that'll get you there. So any number divided by itself gets it to 1. Multiply by whatever gets you to your target. So if you divide this by root 10, it equals negative 1. Times it by 3 gets you to negative 3. That's just a little hack you can use for later, but the CAS solve approach would have been perfectly fine as well. So that is our dilate factor, or at least the number for the dilate factor. Dilate by factor, maybe I should write it in green. Dilate by factor 3 on root 10. Now, the challenge is what we say afterwards. Are we saying from an axis? And if so, which axis is it from? That's the next decision to make. Now remember, the figures I gave you were x figures. It was x spacing. So what is this dilate factor actually from?
Is it the y-axis?
Yes, from the y. Good. A lot of people will accidentally say, because I'm saying x a lot, they'll say x. When you say from a thing, it's going in the opposite direction. So yes, you would say this is a dilate of 3 over root 10 from the x-axis. Cool. That gets us our dilate factor. Now from here, the translations sort of just sort themselves out, because all you got to do is apply your dilate of 3 over root 10 to each of these values, and then whatever's left over, you just sort of map on. So applying a dilate of 3 over root 10 to each of these just means you have 3. Why didn't that write? What? Hello? No way, have I run out of space? Ah, bugger. Alright, just going to use the pencil now. Bear with me. So we had our figures, which was dilate factor of 3 over root 10, and that's multiplying our x's. So it's a multiple of the plus minus root 10 on 2. Now we can just do that on the CAS. That's nice and chill. So we grab our value. Oh, what am I saying? We already know what that's going to make it equal to. It's just going to be the same as the g. Right, that was the whole point. Anyway, so you have your 10 on root 2 multiplied by 3 over root 10. That's going to get you to 3 over 2 plus minus. That's the x coordinates. The y coordinate is going to stay as it was. we applied our dilate factor. That's got our h to now this stage here. We want it to now look like -1, 0 and then 2, 0. So let me just get that on the same page. I'm going to get from there to -1, 0 and 2, 0. What's left over as far as translates go? Maybe I'll even separate this one so it's a bit obvious which one maps to what. So you're going to have a negative version of it, -3/2, -9 on 4. You're going to have a positive version of it, 3/2, 9 on 4. And each of these are going to map to different things. You'd probably pair the negative with the negative and the positive with the positive. We already forced the spacing to be correct on these. So whether you focus on the top one or the bottom one doesn't really matter. You just want to make this look like that, or this look like that. Who's got one? What's one thing we can do to make it look closer? Half unit left for the negatives. Yeah. Oh, hang on. No, right. Yeah, you're right. You fixed yourself up. Cool. That's all right. Well, actually, maybe it's because of the when you had like your x minus h stuff, you kind of default to right means negative. Maybe that's why. Anyway, cool. So yes, we want to go right. So one of the other factors, once you add a half to each of these, that's going to get you to -1, -9 on 4, and 2, -9 on 4, and we'll just write that came about by shifting a half right. Last but not least, just got to make the y's equal to 0. How are we going to do that? X's are all looking good. One final translation. I think everyone's a bit scared of the question now. That or they're off doing something else. Here's a simplified version. You have a point here. The other point is, where is it? It wants to be 2, 0. So you are here. You want to get there. What do you do? Oh, someone's got to say it. Final collaboration before we end the class. How do you move a point upwards?
You add 9 on 4.
Yes! There we go. That's it. Add 9 on 4. 9 on 4 up. Thank God. There's no ace at left again. Brilliant. Love it. Yeah, okay, so just to recap everything. Right, so we had this nasty thing we were told to figure out the transformation set that would get us from the H minimum points to the G minimum points. We didn't know where the well, one of those. I think we didn't know H, so we had to find those, F min or otherwise derivative equals 0. That gives us a target, right? We're trying to get from one place to another place, and so from there you've got to figure out, hey, how do we actually make that happen? One thing to clarify with dilations is that that's all about stretching things. right? And so the goal is to figure out what actually needs to be stretched to make it work. If we were just to shift things horizontally or vertically, we would never actually make it work because the spacings between the minimum points were different. So that's what we targeted with our dilation factor. We had to figure out how to get from this to that. That was with our dilate factor, making sure we set the right axes. Then from there, translations was just a matter of mapping the points onto where they should be. Right, we had our points. This was just simple addition, subtraction to get where we wanted to go. And so as your final answer, you write them in the order that you did them. So we had our dilate factor of 3 over root 10 from x, followed by a shift half by right, followed by a shift up by 9 on 4. That's a summary of all that. 5%er, so, if you felt that was tough, so did 95% of other people. Feel free to stick around for a little bit if you want me to explain any more details as to what was going on there. But otherwise, feel free to enjoy the rest of your day.
Thank you.
No worries. Got a question for me? Or just figuring out how to log out?